All right.
Knock it over.
Yeah, that's right. Oh, this is Brad's. Oh, here it is. Okay. All right. What reaction did I write down?
N2 plus 3H2.
Yeah.
Oh, it's the same one. Plus 91.8 kJ.
Yes, sir.
And the question I asked was, in what direction will it shift if you increase the temperature?
No question.
Oh, I did.
If temperature is decreased, the equilibrium will shift to
If temperature is decreased?
yes. And then, but then you did if the temperature increases on this reaction.
So I did 2 examples.
Yes.
Oh. Well, then we're done with that.
Oh.
Write this down. If the temperature, so put this underneath that. If the temperature on a system at equilibrium, if the temperature on a system at equilibrium is increased, it being the system, will shift away from the heat.
Where's the period in the middle of that?
What?
Where's the period in the middle of that?
Here?
Yeah.
Because that was the end of my sentence.
That's
No.
not that's not a full sentence.
No.
It's funny. You never
That's
mind.
common.
If the temperature on a system is...
No. Wait, then you stop.
Okay.
Comma, how about that?
Well, you need to make that the lowercase I.
You're right, but I'm not going to.
This is like English class.
I know. Just
Lost faith
No,
in you.
the period should not have gone there, but I just don't feel like erasing the I.
Hey, what is that like dot above there?
Yeah, exactly.
I don't know, why don't you put your face real close to it and see what happens. Alright, now, well, I'm not saying anything. If the temperature is decreased, period, on a system at equilibrium, it shifts toward the heat. T-O-W-A-R-D.
I actually just spelled it wrong.
Toward the heat. Is it towards?
yeah.
Well, it could be either one.
That's
No,
happens.
It can be either one.
Yeah.
It's
Okay.
either
No, we're all gonna get cursed
shift
because of that
toward-
uppercase I.
It will shift towards or it shifts.
Did
That's
you say
right.
double
Yeah,
case?
you need an at, you need it shifts
I
towards.
said uppercase.
And then that's not towards.
That's right.
Really?
I think. That sounds it shifts towards.
That I is too
toward.
far away from the T.
It shifts toward.
You know what?
Toward the
Just
heat.
put a line
Okay,
underneath
just
the.
No, no, I don't really care. I'm
You
just
actually
playing
have
the
to
Put a
game.
line underneath
You
the
have to
dots
erase
on
it.
Because
the.
if you have a plural on the
that.
shifts,
You can
then
use
it
the-
would be a singular
Use the
on
dot
toward.
stuck on the
Yeah.
board. as the
So
dot.
if it says shifts, then
Yeah,
it's
it
singular?
shifts toward the heat.
Shifts
Shifts
towards.
Yeah, towards.
Towards the
It
heat.
will,
Just
will
yeah,
shift
it's
toward.
Why
Yeah,
are we
there we
even
go.
discussing
That it
this?
is
Because it's
unsatisfactory.
fascinating.
Look at it, it's all.
So, I could care less about the grammar, but I do care.
About that I this week.
What's that?
He's still complaining about that I.
Yeah, I fixed it.
You could just put, you might as well just put a line underneath
Yeah,
the
put a
dot
line
that's already
underneath the
stuck
dot.
there. Because that I is way too far away from the T.
Oh my
Why
god.
should you use? Yes, there we go.
Alright, in
There
cursive.
you go. So now we're using this stupid spot on my board. I'm getting angry just thinking about it.
Oh,
All
it's
right.
not even there.
Now,
What
anyways, that was the only time I'm ever going to use that thing. So now, I could care less about all the jibber jabber we're having, as long as you can look at a reaction and tell me if it's A plus B yields C and the heat is on this side. We go this way if we increase the temp. We go this way if we decrease the temp. So I could care less about this part, as long as you're able to look at a reaction and tell me which way to shift if the temperature goes up or down. That's what I care about. That's what you're going to care about on your quiz. So, enough with all that jazz. So we did some homework problems. We had a couple practice in the notes. Hopefully you kind of have a pretty good understanding of that. Again, I'll review a little bit the rest of the week until we take that quiz. All right. So, next thing we have to talk about is called the common ion effect.
Yay.
Common ion effect. This one's easy.
Isn't that a children's book?
There's nothing in that. What'd you say?
Isn't that a children's book?
The common ion effect?
Yeah.
Okay. And I'm just going to give an example instead of a definition. So, let's say we want to dissolve silver chloride in solution. So we dissolve it in some water. We get Ag plus AQ and Cl minus AQ. So you take AgCl, put a little S for solid, and then you get Ag plus AQ and Cl minus AQ.
Wait, why now would you put charges on there?
Why now what?
Why would you put charges?
Oh, because this is being dissolved in water.
So now they're becoming ions.
Yes.
Oh.
Once you dissolve something in water, it turns into ions.
Hey.
If it has ions. Sugar doesn't do it because there's no ions, but ionics do. Metal, non-metal, so ion. Focus. So, are you good?
Yeah.
You sure?
Yeah.
Okay. Alright, so, here's a question, a review question. Why does AgCl only have one Ag and one Cl, but if I had calcium chloride, it would be CaCl2? Go ahead.
Because would have to do with the charges.
Has to do with the charges.
Alright, so
Hold it.
because the Cl is -1.
Cl's minus 1.
So that the Ca is -2, so you're gonna need 2 Cls.
Minus
No, I
two.
mean +2.
Plus 2, good.
Yeah, thank you.
So you need 2 Cl's.
Yeah.
You need 2 Cl's to add up to 0.
There you go.
Right, but remember, Carly remembers, no charges on your final answer, right?
Yeah.
No charges on your final answer. So I just want to review with you guys. That's why it's AgCl, not Ag2Cl or AgCl2. Just keep that in mind with those charges. All right, so back to this. So let's say we have a beaker sitting on the table. We have this dissolved in it, AgCl. Let's say it's saturated, so it's at equilibrium. Okay, it's at equilibrium. I'll put that here. It's saturated. Saturated solution of AgCl-AQ. That's what we have. That's an example. That's how we would show it on paper. Saturated solution of AgCl-AQ. Okay. Here's the question. If some AgNO3 solid is added to this solution, so this solution here, the above solution, if some AgNO3 is added to this solution, in what direction will, ooh, the bell's gonna ring, the equilibrium shift? So I'm going to stop. We can answer that tomorrow. Get that down, and then we'll answer it tomorrow. No homework. Tomorrow we're starting a new unit, organic chemistry.
Yay.
Bullshit.
Is it organic?
It is organic.
Yay.